Introduction to PLCs. The multiple choice questions are synchronized with this presentation. The mid-range PLC can accommodate 1024 sensors and actuators. Input modules connect to physical sensors. Several switches are shown in this example. This is a modular PLC showing 2 input modules. Cyclic scan is really the operating system. First it reads the inputs, then it runs the program, then it adjusts the outputs, and repeats the cycle. Most of the time is program execution, which could be a few milliseconds or 100 milliseconds. The PLC program is inserted into the PLC through a handheld programmer, an industrial loader, laptop PCs, and desktop PCs. PLC needs power. The power supply provides power to the CPU and the I/O modules, but it does not power the I/O devices. The I/O devices are the external sensors and actuators that are connected to the I/O modules shown here. The most common PLC programming language looks like a ladder diagram, with sensors on the left and actuators on the right. Another type of controller is a programmable controller. Here are 3 industrial ball-screw linear actuators that are controlled by a dedicated programmable controller called a supercell. That's the industrial controller. It's really a computer. The 3 linear actuators combine to control position along X, Y, and Z axes. Small AC motors in each actuator can position each axis very accurately. The cell controller could be commanded by a PLC. Motors, indicators, valves are actuators that can be connected to the PLC. Output modules connect to the actuators. Shown here are 3 solenoids, a light, and some generic load. This modular PLC has 2 output modules. The central processing unit is where the program is executed. Remote I/O rack could contain I/O modules and a power supply, but no CPU. That's because the CPU that drives these I/O modules resides elsewhere. This rack without a CPU is called remote I/O. Before PLCs in the late 1970s, control logic was implemented in hardware. Here we see some hardwired logic, a few switches, and some loads. They all can be connected together without a PLC. A PLC is a computer between the field input devices and the field output devices. LEDs indicate what's going on in the PLC. There's a fault, AC power, DC power, run light, fault light, battery low, input on channel 0, output on channel 0. PLCs have many features and benefits. Solid-state components is one of the features. benefits include low component failure, low space and power consumption, and no mechanical wear. Each PLC manufacturer offers several different PLCs, each with different capabilities. All the PLCs from one manufacturer is called a family. Here is the Unitronics family of PLCs. The Vision 130 is one of the family members. Unitronics PLCs come from Israel. The I/O system includes the input and output modules. Microcontroller PLC is a low-end PLC. Intelligent I/O means communication with other smart devices. Control memory is located in the CPU. In a PLC system, there's no physical connection between the input devices and the output devices. Many different industries use PLCs. What was used before PLCs? Relays. The advantages of PLCs include solid-state components, flexible computer-based architecture, built to sustain industrial environments, programmable stored program, perform relay equivalent functions, modular interfaces to standard field voltages, easily installed and maintained by plant personnel, and they're reusable.